Okay, this is, I think maybe the fourth video now in the series of factoring polynomials that covers sections 5.5 to 5.7. This specific topic is in 5.6 in our current book, and we're still working on factoring three-term polynomials. This time we're going to talk about polynomials that are in this form of ax squared plus bx plus c, where a is not 1 and it's not a GCF. So I'm looking right here and I go, 3, 19, and 20, they have nothing in common. I'm going to count the terms. I have 1, 2, 3 terms, but this coefficient is not 1, so I can't use hippobuts. Because it's not 1 and this is not a GCF, then I'm going to have to use a different method, and this method is called synthetic factoring. Okay, synthetic factoring. I can spell synthetic factoring. Okay, and the steps for synthetic factoring, here's how we're going to do this. Instead of saying the last number is what times what, our first step is we're going to say a times c. Well, what the heck is a and c? Well, a, you can see, is the coefficient of the x squared term, and again, this is a general term. So this could be to the 4th power, to the 6th power, or whatever the case is. Okay, so but the coefficient is what I'm talking about. That's the value of a. What is c? It's the value of the last term. Coefficient or constant in this case. So a, in this case, is 3, and it's a positive 3. And I'm going to times that by a positive 20 to get the result of a positive 60. Okay, so first step is I'm going to do a times c. Here's the example of that. The next step is I'm going to say the factors of a times c have to sum to the middle term, or in other words, the coefficient of the middle term, which in this case we're going to call b, this middle term right here. So now I'm looking for factors of 60 that will sum to 19. Well, there's a lot of factors. Of course, we could list them all. We could be like, well, there's 1 and 60 and 2 and 30 and 3 and 20, and geez, I'm getting closer here. 3 and 20. 2 and 30, too far apart. 3 and 20. 60 is divisible by 4, and I get 15. It's divisible by 5, and I get 12. It's divisible by 6, and I get 10. It's not divisible by 7, 8, or 9. So these are all of the factor pairs of 60. That was a lot of work just to try to figure out what sums to be. This is going to happen to you. I know this won't work, this won't work. 4 and 15 can sum to 19. That's 17, that's 16, and I can't get 19 there either. So my factor pair here is 4 and 15. So I've picked my factor pair that I can get to sum to be, but I have to choose their signs. So for step 2, I'm going to say the factor pair that sums to negative 19 is going to be a negative 4 and a negative 15. Negative 4 times negative 15 is a positive 60, but negative 4 plus a negative 15 is a negative 19, so that checks out. Okay, so these are my two factors that are going to sum to b. My third step is I'm going to write them over a. Okay, I'm going to write this over a. So a, we already determined in step 1, is 3 in this case. Okay, so this is step 3. Just literally putting them over a, like I'm making a fraction, which might seem nasty, but it's not too bad. My fourth step is I'm going to reduce those fractions if I can, but I'm going to leave a top and a bottom. So I want to make sure that we have a top and a bottom. Okay, so negative 4/3 can't reduce. So for step 4, I'm going to say I have negative 4 over 3. Nothing I can do about that. But 15 and 3 can reduce. They both have a common factor of 3. When I take 3 out, I have 5, and I just have 1. But again, I need to leave a top and a bottom. The reason why I need to leave a top and a bottom is because I need to write them as factors. So now I'm going to write these fractions as factors. Okay, the tip I have here is that the sign, those ones have the sign, so the sign goes behind. This is how I remember. What I'm going to take and do is each one of these fractions represents a factor. So these are my hippobutts. This first -4/3 is my hippobutts, and -5/1 is my hippobutts. Well, how does this transfer to a hippobutt? The sign goes behind, so this is going to be -4 in the back of this one and -5 in the back of this one. Well, what does 3 mean? 3 means that I don't just have a single x, but I have a 3x. Again, I'm going to look at this middle term right here and say there's an x, and that's what's going to go into each one of these. This one just says 1, so I just have a single x. So I'm literally taking this fraction and rotating it 90 degrees. That's how I get this. I've got the 3 and the -4, they go here. I've got the 1 and the -5, they go here. So I'm going to write them as factors. That is this process here, and the sign goes behind. Always, always, always write your signs here and check them. Check to make sure this multiplies to the 60 and sums to the -19. We did that, so we're good to go. Okay, so this is the process for synthetic factoring. We'll go through maybe 2 or 3 more of these, just so we can kind of get the hang of this. We've got this next problem here. 5x squared minus 14x minus 3. Well, I'm going to check first, no matter what kind of method I'm going to use, but first I'm always going to say, is there a GCF? 5 is prime, 14 only has factors of 2 and 7 and 3. So these do not have a greatest common factor. So this is indeed a 3-term polynomial that has a coefficient that is not 1 and also not a GCF. So I'm going to say I'm using synthetic factoring. Step 1 is to take a, which is the coefficient of the x squared term, and times that by a -3. That's going to give me a -15. Now I'm looking for factors of -15 that are going to sum to -14. Well, that's going to be 15 and 1. But what are the signs? Well, it's going to be a -15 and a +1. Let's check this. -15 times a +1 is a -15. -15 plus 1 is a -14. So that checks out. So those are the factors that I need. I need a -15 and a +1. For step 3, I'm going to write these over a, which in this case is the coefficient, which is 5. So write them over a. Step 4, I'm going to reduce these fractions. Both the top and the bottom here have a 5 in common. So I'm going to have a 3 left on top, and when I divide this by 5, I'm going to have 1. We're going to leave a top and the bottom because they're going to tell me these factors. This factor of 1/5 can't be reduced. And now I'm going to write these as factors. Okay, and let's say that instead of these being x squareds, where x's, these were y's. Well, then what would go in the factor here? Well, again, this sign goes behind. So in this first factor pair, which is represented here, the sign goes behind. But I have 1, well, 1 of what? A single y. Here's what this means. For this second factor, I have the sign of +1 behind. The sign goes behind. And I have a 5. Well, 5 what? Well, I'm going to look up here and say I've got 5y. Okay, so this is factored completely. So a couple of notes I want to make. There are other methods. You could factor these by using factor by grouping. You could also factor them using a method called trial and error. In my humble opinion, is that students already feel like they make enough errors, not trying to, that we don't need an actual method called trial and error. Okay, so this is the method that we're going to use, and again, this will be a shortcut later on in the semester. So I want to do 2 more here of this kind, just to go through the steps, kind of get used to what we're doing. So let's do 20x to the 5th plus 54x to the 4th plus a 10x cubed, and we will do y on here plus a 10x cubed y squared. Okay, so first step, always and forever, of factoring is I'm going to see if there's a GCF. When I'm looking at 20, 54, and 10, the first thing I notice is that they're all even. So I know that they can be divided by 2, but can they be divided by something bigger than that? Well, 4 goes into 20, 4 doesn't go into 54, and it doesn't go into 10. Only other factor of 20 is 5, and that's not going to work because it won't go into 54. So we are good to go. So my GCF here is 2. For my constant, when I look at these, I have an x to the 5th here, x to the 4th here, and an x cubed. That means that they all have at least an x cubed in common. This one doesn't have a y, so there's nothing I can do about the y's. So what's left here is a 10x squared plus a 27xy plus a 5y squared. Okay. So I've just done the first step of factor completely. Then I'm going to look inside of here. And when I'm looking inside of here, I'm going to say, what kind of polynomial is this? Well, it's a 3-term polynomial with a coefficient greater than 1 or not equal to 1. So it's in this format. And I'm going to have to use synthetic factoring. When I'm using synthetic factoring, I'm not going to refer to the original polynomial. I'm only going to refer to what's inside these parentheses. Okay, so my first step then is going to be 10, a positive 10, times a positive 5, which is going to give me a positive 50. Now I'm looking for factors of 50 that are going to sum to 27. That's going to be 2 and 25. Again, if you can't pull those out of your hat, then just list all the factors of 50 like we did previously, and then find the ones that you can make work. Positive 2 times 25 is a positive 50. Positive 2 plus 25 is a positive 27. So this checks out. Always perform this check here to make sure you're using the correct ones. So this was step 2. I determined these are the factors I should use. Step 3, I'm going to write them over A, which is 10. And step 4 is I'm going to reduce these fractions. Well, 2 and 10 have a 2 in common. So I'm going to get a plus 1 over 5, and 25 and 10 have a 5 in common, so I'm going to get a plus 5 over 2. Remember that these turn into factors, so let's go. This is one factor and this is another factor. I know that I'm going to have my 1 behind and my 5 in front, my 5 behind and my 2 in front. So again, I'm just rotating these 90 degrees to be this. But now I have to go back to right here inside of this polynomial and say, what do I have? Is it x, is it y, is it z, is it w, is it an x and a y, or what is it? Well, I have an x and a y, and the x's are in front and the y's are in the back. So this is going to give me a 5x plus a 1y, which I'm just going to write as 5x plus y, because 1 times anything is itself. Okay, and then I'm going to have an x in the front here and a y in the back here. Okay, so this is factored, but I also, super important here, I'm going to be like, don't forget me. I've got to bring down this GCF. It is part of my answer. Factor completely. These are all of the factors of this original problem that I was given. Okay, so that is factoring 3-term polynomials that have a coefficient that is not 1 and is not a GCF.